In this video we're going to do some data analysis using the pandas package. The data we're going to look at is a list of hills in the Peak District. So we've got a comma separated values file here which contains all this data. So the first row here is headers, it's a name, and then the height in meters, and the drop. The drop of a hill is kind of how far you have to go down before you can go across to the next hill. And then the latitude and longitude and the county that the hill's in. So incidentally, this data comes from it's a kind of cut down version, much bigger data set that you can download from the database in British and Irish Hills, hillsdatabase.co.uk. But from there I kind of extracted a small subset of their data, which is in this comma separated values file. So we're going to you have to import some packages as usual. We've got NumPy and then pandas package we import as PD, and we're also going to import geopy.distance because we want to calculate distances between various points specified by the latitude and longitude, and it's actually quite a complicated thing to do, complicated formula for calculating distance in terms of latitude and longitude, so we won't deal with that ourselves. We'll use this geopy.distance package. Okay, so now we want to read in this data. So so it's fortunately a kind of very convenient function that we can use to read in a comma separated values file. You just do pd.readcsv, and then this will give us a structure called a data frame, and because it's a data frame we'll call it df. Okay. Okay, so now let's see what this is. Okay, so you just do df, then it gives us a little snapshot of it, shows us the first 5 lines and also the last 5 lines, and you've got the names, the height in meters, the drop, latitude and longitude, and the county, all in this pandas data frame format. A bunch of other ways we can get some information about the data frame without showing all of it. We can do df.describe. So that gives you the number of entries, the mean, standard deviation, minimum and maximum, that sort of thing. We can do df.info. That tells us, again, that doesn't give us any information about the values particularly, but it does gives us the list of columns. Or we can do df.columns. And that gives us the list of all the columns, column headers. We can do df.shape. It tells us 113 rows and 6 columns. Okay. Okay, so let's do various other things. So we can just do, if we just do df meters. Actually, before we do that, let's just also say, remember, we can do type df. That tells us what type of thing it is. It's pandas.core.frame.dataframe. So it's a data frame. Now we can do df meters. So that gives you a just gives us one column from the original data set, all the heights, the various hills. And if we work out what's the type of that, that's a series. Okay, so so in particular, it's not just a NumPy array. It behaves more or less the same way as a NumPy array for almost all purposes. Lots of the times you don't really need to distinguish too much between a pandas series and a NumPy array, but there are some differences which we might get to. But anyway, let's take so let's sort this in order. Okay, so we but actually, so how do I know how to do that? I mean, of course, we can look here for pandas.pydata.org. This is the this is the main site for pandas, and you can get all sorts of stuff here. We can we'll look for okay. So this tells us all about the Panda series data type. Okay. Yeah, so there we go. We've got okay, so we've got this, and notice that we've sorted this into order, but we've still got the kind of original row numbers in the left-hand side. We don't really want those because you know, they'll kind of mess us up. So if we do reset index, then what we've got is we've got a new index. Okay, so now we've got a new index on the left that's kind of counts 0, 1, 2, 3, etc. But it's kind of remembered the old index, which we don't really. It's not going to be useful for us. So you can put drop equals true inside here. It'll get rid of that old index. So now we've got this thing. It's just kind of as a as a list in the right order. Okay, and so now we can plot it. And yeah, so here we can see this is the heights of all these hills. The minimum's around 240 meters, the maximum at Kinder Scout 640 or something. We've got okay, so that's that. Yeah, and then we could also another thing we could do, another way we could display the heights. We could do it. We can do a histogram. Many different plotting methods which you can find, but one of them is we just do .hist like so. So now it's chosen. Yeah, it's divided everything up into different ranges of meters, of heights in meters, and made a little histogram to show how many things there are of each height. If we want to get better control over what the which bins things are divided into, we can put in an extra argument here. Okay, so here we're going to do bins, so we steps of 50 meters starting from 200 up to 700 meters. Okay, so now that's maybe a little bit tidier. We get kind of 2 bins in each 100-meter range. And you know, so we can see, for example, there's just one hill here in the range 200 to 250 meters, and, you know, and 4 of them in the range 600 to 650. And let's we can also put in a legend as well. So this is doing its height in meters. Another thing we could do, yeah, so there we've just done the height in meters. We'd also do the drop on the same plot if we want. Okay, so here I done. So remember here I did df just the string meters inside the square brackets. So that just got me a single column. If I want to get a pair of columns, I can just put the two column names in there, and now I've got actually have to have double square brackets for this. Okay, so this gives me a new data frame in which I've sort of dropped the other information. I've just got the meters and the drop, and so now I can plot. I can do histogram of that. Okay. So if I do, yeah, it's actually if I do a histogram like that, then I get 2 separate histograms. Turns out actually I can do .plot.hist, then it will give me a combined histogram. Okay, so here we've got the same scale. We've got the drop in meters here. That's typically much lower, and then the height in meters is typically higher. So we go, well, always higher for any given hill. So we got to go over to the right here. Okay, so there's some basic plotting things. Okay, so let's do some different stuff. So let's look at the counties. So there's the list of counties. If we just want to see, the list of all the counties that appear, we can do df county.unique. Okay, so that gives us all the. So you can see these strings are not really counties as such. I mean, we have county with some extra information. So Derbyshire / Sheffield, Barnsley / Sheffield. That's not really a county, but it's in the county column anyway. Okay, so so let's so let's try and split these things up and see which words we get. Okay, so we do. We can say. Okay, so we're going to split each of these things across the slash characters. Okay, so now we get all this stuff here. Okay, so so this is kind of roughly what we want, but not quite, because you see we've got a list of lists. We really want to just sort of flatten this out into a single list. So we can do yeah, so you want to say W for S in here. Yeah, so to think about the order of how this is written, you have to kind of think about how you would do it if you were just actually writing for loops in a usual way. So you would write a for loop, you'd write a loop over all the counties, and then inside the loop over all the counties, you would split each county into words, and then you do a loop over that. So this syntax here reflects that. You know, you've got the for S in the list of counties as a sort of outside part of the loop, and then for W in the split thing as the inside loop written afterwards. Okay, so we do that. Okay, so now we've got all these kind of. So we've got everything. We took all the county names and then we split all of them at the slash. So now we've got a bunch of different words. But now, of course, we've got a bunch of repetitions again. It's cropped up now. So, but we could we do curly brackets instead of square brackets. So then that produces a list instead of a set. Okay, and we do a set, so it produces a set instead of a list. And sets kind of don't have repeated elements. If you've got the same element twice in a set, then set counts the same as having it once. So that gives us that eliminates the repetitions. But now let's convert it back to a set, back to a list by just wrapping it in the word list. And there we go. And just to check, I think it's actually automatic. No, this isn't. Yeah, so this is not sorted into alphabetical order. You see, you've got Barnsley, which is first in alphabetical order, coming late in here. So let's put it back in alphabetical order just to be tidy. Okay, so there's our list of just of all the county words. Okay, so let's give this a name. Okay, so that's a little exercise in processing the data. Okay, so another thing we can do, let's work out how far all these hills are from the maths department. Okay, so so here's the position of the Hicks building in latitude and longitude. Okay, so so I want to calculate the distance from the Hicks building. So that's okay, so we're going to need this will be a little bit complicated. Okay, so actually let's break this down a little bit. So okay, so here this is our this is like the 10th row, say. Let's call this row. Okay, and so we want to calculate distance from the Hicks building. So we're going to do So we use this function geopie.distance.distance. That's for calculating the distance between 2 points specified by latitude and longitude. And we're doing it from the Higgs position to the position given in this row. So that's we have to specify this as a tuple, so we put in round brackets. Okay, so we calculate distance here. Okay, so it's given this, but it's not coming out just as a number, but as kind of fancy object here. That's because you have to specify what units you want. I think we can probably do miles if we wanted. It gives us a number in miles, or we can do .km if we want a number in kilometers. Okay, so that gives us the distance. Okay. Okay, so we want to do that for every row, so the kind of approved way to do that is to use df.apply. Right? If we do df.apply and then we give a function, and then and then we can apply that to every row like so. So actually, here we've done it with a lambda. Actually, maybe it's clearer if instead of a lambda, let's define a function. Okay, so then we take this thing here and we take this as we put this into a function. Okay, so now once we've got this function, then we can apply it to and we want to apply this to every row. If we wanted to apply a function to every column, well, that's what df.apply sort of by default it applies your function to every column, but we want to apply it to every row instead. So we have to have, say, axis equals 1. So that'll apply the thing to every row, and okay, so that. So that, oh right, yes, we've failed to put in the return statement. That's our problem. Okay, so that gives us all these distances, yeah. So, but we want to sort of incorporate this into our data frame. So what we're going to do is we just assign this to a new column. We'll call it df distance. Okay, now if we display the data frame, you see we've got a new column listing on the end. Okay. So another little exercise we're going to do is to tidy up the names of all these hills. So actually, let's just because we've got a whole bunch of stuff like this, can we do so here's all the names, and you see we've got some stuff like this: Howden Edge, square bracket, High Stones, Lord Seat, Rushup Edge, etc. That's kind of, it's going to be a bit awkward stuff that we want to do. So we want to get rid of this stuff here where there's extra stuff in square brackets, or it might be at round brackets, or after a dash or something. So we're going to want to get rid of all those things. So we're going to do a string replacement operation. So firstly, yes, whenever you've got a column of strings and you want to do sort of string operations on it, you have to sort of put this dot strut on the end before you specify which string operation you want to perform. That's how it works. Okay, we're going to do a replacement. We're going to do a replacement with regular expressions. So what we're going to do here is okay, so we're going to do we're going to take this here. We're going to do a replacement. So what we're going to replace anything in square brackets. If there's a bunch of stuff, an open square bracket followed by any stuff followed by a closed square bracket, then we're going to replace it with the empty string. So what's going on here? Well, so dot means any character. So dot star means any series of characters. And then the square brackets have a kind of special meaning. So if we just want to refer to a square bracket without having any special meaning, we have to put in the backslash. So here, this regular expression, it matches just an open square bracket, any sequence of stuff followed by a closed square bracket. And whenever we see that, we're going to replace it by the empty string. And so we do that, and okay, so now you see the Howden edge, which used to have a used to have some stuff in square bracket afterwards. We've got rid of that. Okay, but actually the original here we haven't actually replaced anything in the original data frame. We've just sort of generated a new list. So we want to actually change the names in the original data set. We have to do df name equals, and now we've tidied that up. But then we want to do that again with round brackets. And then well, actually we don't want to do this with lists particularly. It was just a thing to make it easier to see what was going on. So we'll take that out, and we'll take that out. And then the other thing is that this, we might end up with some extra spaces on the end of the string after we've done this replacement we just did. So we're going to just get rid of any extraneous spaces on the end by using the strip method. Okay, so now we've tidied up the names. So now we want to work out what type of things these are. You see, most of these things are hills, but some of them are called moor or edge or ridge or something else. So let's try and work out what all the types of things are. We're going to call this the type. Okay, so we take the column of names, and then we're going to apply a function to it. Okay, so again, actually let's define a function to give us the last word. S.split will split the spaces, and then we just look at the last entry in that list. Okay. If we map the last word function, to all the names, and that's what we get. Okay, so but actually let's see what we get. There's a whole bunch of different things that could come out. nab, neb, roaches, moss, all sorts of strange things, but hill is kind of the most common. So let's sort of ask ourselves how common these different things are. So that's another kind of very common thing we might want to do with a data set. We want to kind of group it and yeah, so here you've got the you count it. This is counting the number of hills of each type. But yeah, this is actually giving us a whole load of irrelevant stuff, right? I mean, the numbers are kind of the same in every column. So yeah, we don't really want that. So we should just just count the name, right? So now, yeah, so that kind of gets rid of the useless repetition and just gives us the counts for counts for numbers of hills of each type. And so let's give this call this thing DFT is this data set here. Okay, so let's actually just say there's a bunch of things where the count's only equal to 1. So okay, so yeah, so this is just a series instead of a data frame. So yeah, we can okay, so here we do it in descending order. So we see the most popular type is a hill, and then there's some 33 hills, 13 edges, 9 moors, and so on. Another kind of thing we can do with group by is we can so here's a slightly more flexible way to sort of aggregate stuff. So we want to get the count. So we do this, yeah. So this is kind of more like another way of doing what we did previously. So we've got the types here, and then the count of how many things there are. But then we can also put in inside this aggregator function. We can do another thing. We can do okay, so here we're going to aggregate the height of the meters, but we're going to take the mean, right? So this is going to give us a new column in here, which gives us the average height for things of each type. Okay, so we see that for things that are called hill, the average height is 427 meters. Things that are called rocks, the average height is 419 meters. Okay, so let's call this guy DFT. This is our data frame by type, the data frame of types. Okay, and then we can okay, so let's okay, so now we can cut down this data set. We can only consider types for which there's at least 3 hills of that type. Okay, so that gives you this shorter data set here, and then we're going to we'll sort this in order. We'll sort it by the height. And again, we'll do it in descending order. Okay, so we see that the things called head have the highest, and then things called tor, things called moss, edge, and so on, and the hills are somewhat lower. So that's a basic introduction to the kind of data analysis that we can do with pandas.